When you're tapping into an existing 1200 amps multimeter center to feed a combination Milbank meter main breaker unit, the connection from the multimeter center to the new meter unit is indeed considered a feeder. This is because it supplies power from one point, the multimeter center, to another point, which is the Milbank unit. Now let's talk about the wires on the line and load sides of the Milbank unit. The wires that connect to the incoming power source, which in this case is the multimeter center, are considered the line side. The load side, on the other hand, refers to the wires that connect to the outgoing power circuits. These circuits will then supply power to other equipment or buildings. Keep in mind that the Milbank unit serves a dual purpose. It acts as a metering device to measure energy consumption and also houses a main breaker to provide overcurrent protection. Since the Milbank unit is located within 10 feet of the multimeter center, it's generally considered a short feeder. This means you typically don't need to worry about specific distance or routing considerations that might apply to longer feeders. However, it is crucial to ensure that the wiring is sized appropriately based on the current capacity of the feeder and the connected loads. Also, remember that the entire installation must comply with all applicable electrical codes and standards, including the National Electrical Code, or NEC. Now let's delve into the concept of feeders a bit more deeply. A feeder, in electrical terms, is a set of conductors that originate at a source of power, such as a service equipment or a separately derived system, and extend to one or more branch circuit overcurrent devices. Feeders carry the bulk of the electrical load from the source to various distribution points within a building or electrical system. Understanding the correct terminology is essential for clear communication and compliance with electrical codes. Misunderstanding the definitions of feeders, branch circuits, and service conductors can lead to improper installations, safety hazards, and code violations. Now let's elaborate on the line and load sides. The line side of any electrical device or equipment refers to the terminals or connection points that are connected to the incoming power supply. It's the side that's electrically closer to the source of power. The load side, conversely, refers to the terminals or connection points that are connected to the outgoing circuits or equipment that will be using the power. It's the side that's electrically closer to the load or the point of consumption. In the context of the Milbank unit, the line side is where the wires from the multimeter center connect, bringing power into the unit. The load side is where the wires connect that will carry power to whatever distribution panel or equipment the Milbank unit is feeding. Now let's discuss sizing the feeder conductors correctly. This is a critical aspect of any electrical installation. Improperly sized conductors can lead to overheating, voltage drop, and potentially dangerous situations. The NEC provides specific guidelines for determining the minimum size of feeder conductors based on several factors, including the load they will be carrying, the ambient temperature, and the type of insulation used. To properly size the feeder conductors, you'll need to perform a load calculation to determine the total current that the feeder will be required to carry. This calculation should take into account all of the connected loads, including lighting, receptacles, motors, and any other equipment that will be drawing power from the feeder. Once you've determined the total load current, you can use NEC Table 310.15, B16, or other applicable tables to select the appropriate conductor size based on its ampacity. Ampacity refers to the maximum current that a conductor can carry continuously under specified conditions without exceeding its temperature rating. It's important to choose a conductor with an ampacity that is equal to or greater than the calculated load current. In addition to the load current, you also need to consider any applicable directing factors. Directing factors are adjustments to the ampacity of a conductor that are required under certain conditions, such as when multiple conductors are bundled together or when the ambient temperature is high. The NEC provides specific guidelines for applying directing factors in various situations. Voltage drop is another important consideration when sizing feeder conductors. Voltage drop refers to the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop in feeders to no more than 3%. To minimize voltage drop, you may need to increase the size of the feeder conductors beyond what is required for ampacity. The NEC provides formulas and guidelines for calculating voltage drop and determining the appropriate conductor size to meet the voltage drop requirement. Now let's discuss overcurrent protection for feeders. Overcurrent protection is essential to protect the feeder conductors and connected equipment from damage due to overloads or short circuits. The NEC requires that feeders be protected by overcurrent devices, such as circuit breakers or fuses, that are sized to protect the conductors in accordance with their ampacity. The overcurrent device should be located at the point where the feeder receives its power, such as at the multimeter center. The size of the overcurrent device should not exceed the ampacity of the feeder conductors, unless certain exceptions apply. It's also important to consider the interrupting rating of the overcurrent device. The interrupting rating refers to the maximum fault current that the device can safely interrupt without being damaged. The interrupting rating should be high enough to handle the available fault current at the point of installation. In addition to overcurrent protection, feeders may also require ground fault protection, depending on the specific application and the requirements of the NEC. Ground fault protection is designed to detect and interrupt ground faults, which are unintentional electrical connections between a conductor and ground. Ground faults can be dangerous and can cause equipment damage or electric shock. The NEC provides specific guidelines for when ground fault protection is required and how it should be implemented. Now let's discuss the National Electrical Code, or NEC, which is a widely adopted set of standards for electrical installations in the United States. The NEC is updated every 3 years and provides comprehensive guidelines for all aspects of electrical wiring and equipment installation. Compliance with the NEC is essential to ensure the safety and reliability of electrical systems. The NEC covers a wide range of topics, including wiring methods, conductor sizing, overcurrent protection, grounding, and equipment installation. It's important to be familiar with the specific requirements of the NEC that apply to your particular project. When installing a feeder, there are several specific NEC requirements that you should be aware of. Firstly, you must ensure that the feeder conductors are properly identified and labeled. This includes marking the conductors with their voltage, ampacity, and function. Secondly, you must ensure that the feeder conductors are supported and secured in accordance with the NEC requirements. This may involve using cable ties, straps, or other approved methods to prevent the conductors from sagging or becoming damaged. Thirdly, you must ensure that the feeder conductors are protected from physical damage. This may involve installing the conductors in conduit, raceway, or other approved enclosures. Fourthly, you must ensure that the feeder conductors are properly grounded. Grounding is essential to provide a path for fault current to flow back to the source, which helps to protect people and equipment from electric shock. The NEC provides specific guidelines for grounding electrical systems and equipment. Remember that electrical work can be dangerous and should only be performed by qualified and licensed electricians. Always follow all applicable electrical codes and safety precautions to prevent accidents and injuries. If you are not comfortable performing electrical work yourself, it's always best to hire a professional electrician. Now let's revisit the specific scenario. You're tapping into an existing 1200 amps multimeter center to feed a combination Milbank meter main breaker unit. The fact that the Milbank unit is located within 10 feet of the multimeter center simplifies things somewhat, as it eliminates some of the concerns associated with longer feeders. However, all of the fundamental principles discussed earlier still apply. You still need to perform a load calculation, size the feeder conductors appropriately, provide overcurrent protection, and comply with all applicable electrical codes. In this situation, it's particularly important to carefully inspect the existing multimeter center to ensure that it is in good condition and capable of handling the additional load. You should also verify that the multimeter center has sufficient capacity and overcurrent protection to accommodate the new feeder. Before beginning any work, it's essential to obtain all necessary permits and approvals from the local authorities. Electrical inspections are typically required to ensure that the installation complies with the NEC and local codes. Now let's talk about the importance of proper documentation. It's always a good practice to document your electrical work, including the load calculations, conductor sizes, overcurrent protection details, and any other relevant information. This documentation can be helpful for future reference and can also be required by the local authorities. Finally, remember that safety should always be your top priority. Always de-energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. And if you're ever unsure about something, don't hesitate to ask for help from a qualified electrician. By following these guidelines, you can ensure that your feeder installation is safe, reliable, and compliant with all applicable codes and standards.